Well, science is an amazing thing, isn't it? Thank you very much, Mr. Chairman, for your kind invitation to me to take part in this Congress. I am very grateful for the organizing committee for the chance to speak to you now. And also I would like to say that I've been really impressed by statistical reports I listened to very recently. I'm a biochemist by profession, and a co-author of my report, Mr. Andrew Ivanov, is a theoretical physicist. And to my understanding, statistical criticisms to radiocarbon dating depends on pre-assumptions. You can prove many things by statistics depending on what you would like to do with the statistics. Statistics is just an instrument, just a language. But it's very important language because it's impossible to be confident about the significance of any data without statistics. The aim of my report is to pay your attention to some still unknown facts from the area of biophysics. Radiocarbon and radiometric assays in biochemistry and biophysics in respect to ecological studies is my specialty, starting with 1979. First of all, I would like to pay your attention for the fact that in order to understand the calendar age of any archaeological object, you should know not only the content of carbon-14 in this sample, but also you should choose a normalization standard called as carbon-13 normalization standard. And delta carbon-13 is a very important parameter for the further calculations. Of course you know that. But there is one pre-experiment a priori assumption in the basis of method developed by Stever and Pollack and then accepted by Damon in his publication in Nature. Namely, according to this assumption, at the point of time point zero, it means in the point of manufacturing of the linen of the shroud, the content of carbon-14 in the flax and the content of carbon-14 in the resulting linen should be equal. And this is a very important assumption, and I would like to please show us the slide number 1. But this assumption is wrong because this assumption didn't take into account a known fact of non-random distribution of heavy and light isotopes between major biological molecules in the flax. This is our data. We have analyzed different species of flax cultured in Central Russia and Middle Asia, for instance. This is the chemical composition of flax stems, and you can see that over or almost 60% by weight is a cellulose or polysaccharide, and the rest belongs to proteins, lipids, and nucleic acids. But the content of carbon-14 in cellulose is much higher comparative to other chemical compounds. The procedure of manufacturing of linen from the flax includes a total removal of everything except of polysaccharides from the flax. And keep in mind that 60% of chemical composition of the flax is polysaccharides, but 97% of chemical composition of the resulting linen is cellulose or polysaccharides. And this compound is especially enriched by carbon-14. It means we have to be very careful in our choice of delta carbon 13 standard for normalization. The people who published a report in 1989 in Nature accepted normalization standard equal to 25 because 25 looks like the value of this parameter appropriate to a total unfractionized homogenate of the flax. But if you would take into account that only polysaccharides are especially enriched by carbon 14 and only polysaccharides are the major chemical compound of the resulting linen, you should understand that we have to choose another standard, more representative, which is equal approximately to 19 per mil instead of 25. If you would incorporate just that value of normalization standard into the conventional procedure of calculation of dating, you will receive very soon much older result than they did. Next slide, please. I'm very grateful to Mrs. Ostervik, to Dr. Ostervik, for her idea about the significance of temperature treatment of the linen, because it's well known that temperature could be a stimulus for a so-called reaction of isotopic exchange. Reaction of the isotopic exchange should be defined as a reaction of spontaneous exchange of different isotopes of one and the same element between solid phase and gas, or gas and liquid phase. We have consulted to specialists in fire investigations in my country as well as in Britain, and we have carried out a special experiment. We put samples of modern and old linen into a closed chamber, and we created an artificially done, of course, atmosphere containing of water, carbon dioxide and carbon oxide, which is a normal contamination of the atmosphere during the fire. We heated this sample for an hour at 140 centigrade. And as you can see, we have demonstrated a real exchange of isotopes between linen and atmosphere. The carbon 14 from the atmosphere came from the atmosphere to the matter of linen, like that. And we have demonstrated the 40% enrichment of the linen by carbon 14 and 25% enrichment of linen by carbon 13 during this experiment. Even 30 minutes of incubation was quite enough to promote this kind of isotopic exchange. It's very hard to interpret this data in one way, of course, but the only significance, to our understanding, the only significance of this data is the fact that thermal treatment, even gentle, even treatment which could not lead to a physical destroyment of the linen, could be enough to promote a real and significant exchange of carbon 14 between gases, and which is normal result of any fire, and the linen. So, in a dating, in a radiocarbon dating, there is a very special problem, which is a problem of calculation for so-called relative error in dating. Next slide, please. We have developed, using our understanding of the significance of thermal treatment, as well as using our understanding of possible corrections in our choice of normalization for delta carbon 13. We have added something which based on these facts we received in our lab, plus on the general understanding of the general logic of radiocarbon dating. Computerized resolution of this system of 5 equations gave us different data from demons, because we incorporated nu, which is relative error in dating, depends on our experimental data. So we have recalculated those numbers, those values of carbon-14 analysis given by people who published their paper in Nature, taking into account our facts and these equations, and we have obtained a different result. But before I will say about this result, I would like to pay your attention to the last of our experiments. Please show the next slide. Next slide, no. Next one. Oh. The fourth. We have received a unique linen sample from the Middle Asian Ethnographical Museum. Yes, please, thank you. This is white color, non-dyed sample, well-known aged sample of linen manufactured in Bukhara Emirate on that age. And this linen was dated by stylistic details and archaeological evidence without any radiocarbon methods. And this is a very well-known historical example. Then we put this sample into our procedure of experiment for conventional and modified radiocarbon calculations. When I said modified, I mean first of all using another biophysically motivated, biophysically chosen carbon-13 normalization standard. When we have used conventional method for calculation of radiocarbon age, we received a significantly younger result as compared to archaeological one. Then after thermal treatment, we have received more older result, artificially of course. When we have used our correction for another biophysically motivated carbon-13 normalization standard, we received closer to right data, but still older. And of course we see that thermal treatment is able to promote an artificially old values of the age, which is a consequence of, as we believe, which is a consequence of our isotopic exchange reaction. But if you would incorporate, like we did in our equations, a new parameter, which is relative error of the dating, experimentally shown in our experiments, plus a new normalization, biophysically motivated carbon-13 normalization standard, you will receive, probably like we did, close enough, more right data as compared to archaeologically evident. So everything stated above makes it possible to conclude, as we believe, that the reason why Damon et al. Did receive wrong younger results in the dating of the shroud, there are at least two reasons for this error, for this mistake. First, the wrong choice of normalization standard without taking into account the procedure of manufacturing of the linen from the flax, and without taking into account the order of distribution of carbon-14 in the flax. And the second, very possibly that temperature-induced reactions of carbon-14 and carbon-13 exchange had a real and significant impact to the content of carbon-14 in the shroud, and the result of that, the shroud was dated as Middle Eel. Then, finally, I would like to say that our approach is not a method. We have to improve and develop that for sure, and this is very beginning, probably. But what we have to conclude even now, even using our fresh result, is, according to our recalculation using these equations, the data measured by group led by Damon et al. In 1988-1989 are enough to conclude that the calendar age of the shroud could be not less than 1,900 years before present. I understand that this is a great responsibility to make such conclusions, and that's why I'm trying to use my poor English language to be very careful. But I would like to note that we have to develop this approach. This is not method yet, but approach. But even now, this approach is fruitful enough to conclude that the wrong results in radiocarbon dating should be corrected using our experimental data and using our theoretical statements. Thank you very much for your attention. And by the end, I would like to express especially my greetings, my gratitude, not greetings, excuse me, my gratitude for Ms. Sibertu for financial support of our lab during this research. And plus, I would like to invite anybody of you to come to Moscow to my lab, and you will see everything we have. Ms. Sibertu, as well as other radiocarbon scientists all over the world, were in my laboratory many times. We are very open, and I hope that God will give us a chance to cooperate with many people. And thank you very much again for your patience.